You know, the AI boom is creating this massive, unseen crisis right here on Earth. It's a crisis of energy, a crisis of water, and just running out of land. And as that demand just keeps skyrocketing, the biggest tech companies in the world are being forced to look at a solution that is, literally, out of this world.
All right, so here's how we're going to break this all down. First, we're going to look at AI's insane thirst for power right here on the ground. Then, we'll blast off and explore this wild idea of putting data centers in orbit. We're going to crunch the numbers on the carbon payback, face the pretty scary dangers of space junk, and finally ask, is this whole thing just a galactic gamble?
Okay, so before we look up at the stars, we really need to look down at our feet. To really get why anyone would even consider launching a data center on a rocket, you have to understand the sheer scale of the problem AI is creating right here on the ground.
I mean, just look at this number, 750 million liters. To put that in perspective, that's enough water to fill 300 Olympic-sized swimming pools. And that's not for a year of AI or even a month. No, that's what it takes to cool the servers for one single training run of a big AI model. It's a staggering amount, and it really shows you the crisis that's brewing for AI's growth.
The reality is our data centers here on Earth are being pushed to their absolute limit. Some projections show that by 2035, AI could be eating up to 4% of all electricity on the entire planet. We're running out of power, we're running out of water, and we're running out of land to keep up with our own demand.
And that right there brings us to the proposed solution. And it is, without a doubt, one of the most ambitious ideas ever cooked up, taking our data centers and literally moving them into space.
So what exactly is an orbital data center, or an ODC? Well, it's not just, a server floating around up there. It's a vision for a huge, interconnected network of satellites, basically a supercomputer in the sky, built specifically for the crazy intense demands of AI. So you gotta ask, why on earth would we go through all this trouble? Well, it really boils down to three huge advantages. First, you've got power. In what's called a sun-synchronous orbit, these satellites get non-stop, unfiltered sunlight. That's about 40% more intense than what hits the ground. Second, cooling. The minus 270 degrees Celsius vacuum of space is the perfect natural radiator. No water needed, at all. And finally, independence. This whole approach could completely separate AI's growth from our planet's already strained power grids.
Okay, this is where we get to the absolute heart of the debate. Because let's be real, launching rockets creates a massive carbon footprint. So we have to ask the big question. Is the environmental cost of launching these things worth the payoff in the long run? Let's do the math.
The key metric here is something called PUE, or power usage effectiveness. The easiest way to think about it is like this. For every single watt of power a data center pulls from the grid, how much of it actually gets used for computing? A perfect score is 1.0, which means zero waste. A typical data center on Earth scores around 1.2, meaning 20% of its energy is just wasted on things like cooling. An orbital one, though, it could get to a nearly perfect 1.05.
And here's why that PUE score is such a game changer. On Earth, a huge slice of the power, sometimes as much as 40%, is just thrown away on cooling systems. In orbit, that waste is, well, it's almost completely gone. Nearly every single watt of solar power goes directly into computing. That's a fundamental shift in efficiency.
But first things first, you've got to pay to play. And this is what we can call the launch debt. A single SpaceX Starship launch, packed with these compute satellites, is estimated to create a carbon footprint of about 4,125 tons of CO2 equivalent. That's the big upfront environmental cost you have to overcome.
But as soon as it's in orbit, it starts paying you back. That same group of satellites, running on 100% solar power, avoids about 16.2 tons of CO2 emissions every single day, compared to if it were running on a standard fossil fuel-heavy power grid down here. And that's the carbon dividend.
So here it is, the crucial calculation. You take that launch debt, you divide it by the daily carbon dividend, and you get the break-even point. And the answer is just 254 days. In less than 9 months, an orbital data center could completely pay back its launch emissions. And for the rest of its 5-year lifespan, every single calculation it does is effectively carbon negative compared to doing it on Earth.
So the math looks pretty good, right? But, and this is a huge but, that clean computing promise comes with some serious cosmic baggage. Now we have to look at the other side of the coin, the enormous and frankly scary challenges of actually building all this stuff in orbit.
Yeah, check out this quote from the think tank Carbone 4.
it really gets to a much deeper, almost philosophical question. They're basically arguing that, okay, even if orbital data centers are cleaner, shouldn't we first be asking if we should just reduce our data consumption, practice a little digital sobriety, instead of just finding a new place to put it all? And then you have to wrap your head around the sheer scale of it all. These are not small projects. We're talking about tens of thousands, hundreds of thousands, and in SpaceX's case, a proposal for a 1 million satellite constellation. The ambition here is to turn low Earth orbit into a very, very crowded place. And all that traffic leads to a nightmare scenario called the Kessler syndrome. It's basically a chain reaction. One collision creates a cloud of debris, which then causes more collisions, creating even more debris, and it just keeps going until low Earth orbit becomes a lethal, unusable minefield for centuries. And with some recent satellite breakups, this isn't just a theory anymore.
And what about the actual computers? On Earth, if a server fails, you just swap it out. In space, the hardware is getting blasted with radiation 24/7. A single chip that's hardened against radiation can cost $250,000. And maintenance? It's either done by robots or it's just plain impossible. That means these incredibly expensive satellites are basically disposable, designed to just burn up when they re-enter the atmosphere.
So this is the choice we're facing. It is a massive, high-stakes gamble between continuing to strain our own planet or exporting our industrial footprint to space, which comes with a whole new set of terrifying consequences.
And if you really want to understand the scale of the ambition, just listen to this quote from a SpaceX filing. It's not just about building better data centers. For the people pushing this, it's about changing humanity into a civilization that can harness the entire energy output of our star. It's a vision of almost limitless power.
And don't make the mistake of thinking this is some far-off science fiction fantasy. The race is already happening. I mean, just in the last couple of years, we've seen major white papers drop, we've seen the first high-performance GPUs actually get deployed in orbit, and we've seen all the biggest players file plans for massive constellations. This is happening right now.
So ultimately, it really does come down to this one fundamental trade-off. Do we stick to the terrestrial path, where the growth of AI is going to be limited by the very real physical constraints of our planet, or do we take the orbital path, unlock all this incredible energy, but risk creating a permanent global problem for every single person right above our heads?
It all boils down to this one simple question. Is this a brilliant leap forward, a genius way to let our digital world expand while keeping Earth safe? Or are we just taking our consumption, our waste, and our problems and just kicking them upstairs? The answer to that is going to define the next 100 years, both here on Earth and up in the stars.